Hey guys, welcome back. Today we're going to be doing a tutorial on this simulation of like this branching or marching paths thing. The idea is we have particles, we're displacing them along a vector, and then randomly we will rotate that vector displacement by about 30 degrees or whatever angle you want, and it will branch and kind of do its own thing. I kind of was thinking about this when I was looking at circuit board design and thought kind of these like fun 60-degree angles were pretty cool. Yeah, it can kind of be whatever you want it to be. But yeah, that's kind of what I was thinking about. So let's dive into it. And this time I'll make the particles way bigger so we'll be able to see it. So we're in the system. We're going to geometry nodes, the new genode system. We're going to delete the input and type in a point, not instance on points, but a point right here. Perfect. That's going to come through or make it way bigger, like 0.5, so we can see it. Okay, so let's think about this. It's going to be a simulation. So we covered that last time. So I have simulation nodes. We're going to pipe it through here. Holding Alt, connect. Nice. Okay, so let's think about this for what we want to do. We want to have this point here. We want it to go along a direction. And at a certain point, let's say here, go one of three ways. We want it to go up 30 degrees, down minus 30, or stay the course at 0. That's kind of the idea, and that's how we're going to do it. So let's first just prove we can displace it along the right way. So we're going to do a vector rotate and a set position node. Great. Okay. So along this, we're going to choose the axis where we want it to rotate. And so we're going to have, and also we're going to choose the general vector for what's going to be done. I think I want to have it be top down. So I'm going to choose the Z axis to make it really easy. It's the same thing as just choosing this axis angle here to 1, so it's the same thing, but let's choose Z to make it a little bit more clean. The vector coming in, we want to define, so we'll say vector. And I want to say it goes along the Y axis first, right? So let's just write that in. So let's say 1. Let's pipe that in. Let's put it in the offset. And then let's just see what happens. Great. So if we just play the animation, we're seeing it displace 1 unit along this grid on each frame in the Y direction. And then if we were to change the angle by 30 degrees here, we're seeing it displace. That is expected behavior. So then all we're going to want to do is then have these points captured in another simulation zone at the end. Simulation. I'm going to capture these points here, join geometry, pull it in here, and then go back to the beginning. So we're capturing those points and it's looking good. Great. Okay. So the displacement is looking good. And now we're having it move as we would expect. So we want to make sure we add in some random noise and kind of make the algorithm for the points themselves to move how we'd want to see. So let us look at that now. Okay, so we're going to want to use random numbers in order to define which the angle is going to be for this vector rotate for how we're going to make that work. So let's think about this. We're going to want to do a random number. And then to make it easy, we have 3 options. Let's use an integer. And let's go from -1 to 1. So now we know for this, it's going to be a random value for that. But let's also add in a frame scene time node. Scene time. Let's take the frame, plug it into the seed. So for every frame, it's going to be a new value for there, which is good. And then we're going to pipe this. I guess let's just see what happens. We pipe it into here. What do you think's going to happen? It's going all over the place. We're getting all kinds of strange movement. It's looking good though. So what I also want to do is not just have it every time update to a random position. I want it to remember the position of it, right? So I want to almost have this angle right here be added to over time. So I don't want it to be randomly going around. I want it to be remembering the direction it's facing. So if at the very beginning, the angle is 0, then we're going to want to shift it depending. So how are we going to do that? We have these random values. We're going to want to multiply this. So it'll be a math node by 30. So now we're going from -30, 0, and 30, right? That's now the 3 options we have coming for all the random values right there. And then we're going to want to also then convert this to radians. So we're going to say 2 radians right here. So now we have it as radians. At the very end, And let's see what happens. Again, we don't have it remembering the history, but we're seeing it kind of go up and back as we would expect to see. Okay, so let's make sure we can find a way to sum up all of these angle changes over time. We're going to do that through a named attribute, store named attribute. And let's say angle sum. So that's coming in. And let's actually move it to the end of the chain. So all this is calculated at the very end. When I was playing with this before, it mattered if it was before or after the supposition because there was some weird kind of like float point error or something as it was recalculating things. Let's make sure this all is calculated as we would expect first. So this offset, let's first think about this. So this is going to be the angle change. So we have this coming in, right? So let's just first, I guess, just duplicate this. I guess we just delete it. Cool. We have this coming in to do the angle. So we know it's coming in to, here we go. Let's keep it in just these numbers so it will make sense. And if we look at this, the points, we can check the angles to make sure it's making sense. Cool. So this angle sum is going to be all of these things added together. So we'll do a math node, this plugging in here, and we're going to do a recursive instance, or I guess we'll do a named attribute. This exact thing, angle sum, piping in. So now we have all of this coming in to see if it adds correctly. It's looking correct. So 30, 30, 60, 90, it seems to be adding or subtracting. Let's also make sure we capture this random value so we make sure this also makes sense. So let's say rand angle, let's capture this and check it one more time. Now let's see if the math is working as we would expect to see. So we have, it's almost working correctly, but it seems to be off here. So we're seeing it go from 30, 30. After these first two, it starts to be working, it looks like. So we're seeing it says 30, 30, it should go to 60, it's not. Goes to 60 here after. So the first one is for some reason being forgotten. So let's make sure we have a way to capture this correctly. Let me just remove this set position for now. Nice. So we see that the angle sum seems to be working. Okay, I'm back. Actually, I think it's correct because I'm looking at the indexing. I think it's just it's firing a bunch of the same ones right there. So if I did one, it should work. Yeah, I think it's working correctly. It's just at the higher amount, it was firing too many at the same spot. So I think it's actually fine. I think it's fine like this way. So this is kind of how I'm calculating it though. So I have the number calculations and then the set position. So that way it's not, that way it's sequenced correctly. It makes sense that way, I think. Okay, so then let's make sure we limit the number of changes by adding a Boolean with a switch in this angle sum function in order to change it essentially. So we're gonna want to switch the random angle because this may or may not. Actually, we're gonna want to switch here, right? We're gonna do a switch function. Essentially, we're gonna want to do this, right? We're gonna want to switch like a percentage of the time that like we add essentially. So it's gonna be a switch here. So some percentage of the time it will just be this, and some percentage of the time will just be that, like this. And then the switch logic is going to be this. So just a bool random value, and we can just do a Boolean, and we can just say like 18%. So 18% of the time it will be true, the rest it will be false, which means it will be adding in. Does that make sense? I think actually when it's true, we want it to add, and that makes sense, yeah. And let's just make sure we track this correctly. So let's just say a Boolean and track that. So let's look at this now. Is it working at all? Might have broken it. So let's just do like 50%. Right. It's called random angle again. Bool angle. Now let's try. There we go. So where is it being true? Bool angle. None of it is true. Does that make sense? No, that looks wrong because if this makes no sense. So if it's all false for some reason, let's say like 0.5, half of it should be true. What is happening? Oh, the seed isn't changing. That's why. Okay, so for the seed, We go here, and we're gonna do the same thing, just a different value on this. Maybe like 4. Here we are, nice. And we can lower it down, and we're now getting different behavior of the points, which is good. So I think this should be flipped. So if it's true, it should just be an angle sum. So let's still double check this. So it's saying this is false, 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 false. It's adding up. We're gonna flip this, so Alt S. There we go, now it's looking better. Let's try it again. There we go, look at that. It's cleaned up, it's way less often, and it's looking pretty close. Well, let's double check the math in the spreadsheet. So we're seeing the angle be 0, 0, 0, 0, 0, the values are 60, and it's saying yes, now it's 60. It's saying yes, it's saying 60 because it was at 0. It's saying yes, it's minus 60, so it's going to 0, perfect. Saying yes, 0, perfect. So now it's looking pretty good. Cool. So we have these, and then what we want to do is do the classic trick to turn these into curves. So let's do that really quick. We go over here, say points to curves, and then we're gonna say it works the 1. But then let's also do mesh or curve to mesh, so you can see it. And let's say the scale. Let's do curve circle. Let's do 16 and like 0.5. Let's see how this looks. Okay, it looks fine. Even like maybe 1. Cool. And then we want to do also back here. If we add extra points right here, 5, it breaks. Looks cool though, but it breaks. So we're going to do the same thing. We do store named attribute, curve ID, ID. We're going to do an integer, grab that curve ID, named attribute, curve ID. And we pop it into here. Nice. Now we're getting these little designs. Isn't that cool? I wonder if we can change the spline type. Points to curves, set spline type. What happens with this? Let's find out. It's a bit more smooth. It has better junctions, don't you think? I think so. And then I think it's looking pretty cool. So we kind of have this evolving little simulation of branching paths and kind of these little pipes moving all around, which is pretty cool. I think we could also we could layer in more noise if we wanted to have it also go up and down as well. But that would be more of stacking to kind of have some 3-dimensional movement, right? So now we have the 2-dimensional in this plane. We have here and here. We want to have it come up here as well. We'd have to add in logic for when it would take a turn up and down. So we could do that, but I think just for now, for the base effect, I'm going to leave it like this, add a material and render it out. But if you guys want to know how to do it with the 3D extra kind of turn, let me know, and maybe I'll make a follow-up tutorial really quick showing you guys how to add in the extra logic. But anyways, what's cool about this is it's all kind of procedural. So let's add in, let's pull out some parameters. So let's say group output, or group input, my bad. So we do group input. Let's pull in this. Let's call this angle turn. And let's call this noise, or it's like, it's like seed change. We can grab another one, probably the probability. So let's grab this, pop that in here. So probability turn. And then anything else that'll be interesting. Number of points, probably. Count up here. Number of points. Let's move that up if we can. So there we go. Number of points, angle turn, cool. Let's look at the layout view. And then let's click into the system. Let's look at this. Let's make it 10, pull it back. Now it's really kind of branching out. And we can make the angle turn, let's make it 72, so it's gonna be a pentagon. See how it changes it. Now we kind of have this branching path effect. I think I might add just one more thing. I'm gonna do a set curve radius. And we're gonna do a float curve and then spline parameter on this. The other way around. Maybe it doesn't work anymore with, nice. I think that adds a bit actually. Set shade smooth, set material. I liked the 60-degree angle though. Nice, I kind of like this little like cyber design thing, it's cool. And we can do the probability turn, really increase it up, and it really spirals out closer to the center. Geometry nodes, math, group. And then this would be nice. So you can change that too. Yeah. It's cool. It's a new design each time, which I enjoy. Let's just look it over one more time. So this was a geometry node simulation for how we took some points and we were able to come in and then basically from the points, we were able to then displace it along an angle. So we wanted to store some values as we're doing that to make sure it's working out correctly. We had a random angle for how we're going to, distribute those points, and which is going to be based off of an integer to go from -1 to 1. So we have the 3 versions of the angle we want. We can go from, if we're doing 60 degrees, it could be from -60, 0, or 60. So it's nice, clean differentials between those 3. That's being stored in a value. That way we can kind of QA as we're going. We're also storing a Boolean angle probability to make sure we know if we're actually going to add it in. That's using a switch node between the angle sum as well as the angle sum with the random angle adding it in. So if it switches and it's false, we'll just going to return the same angle sum. But if it's true, it will add in the new value down here, right? That's being put into a set position, which is on a very simple vector rotate. We're choosing a direction with the vector, and I'm just initially choosing going in the positive direction on the y-axis. And then I'm making sure to take the angle sum and returning it back into radians in order to make sure the vector rotate works, because it's looking for a radian, even though it says right here an angle. It's actually wanting a radian. It's lying to you. That comes into the simulation nodes. And then we're just going to store those points over time with another simulation, set the curve IDs beforehand. So we capture that nice clean attribute, put it back into curves, and we have this nice kind of fun design. You set a material and you kind of make a whole scene and you're good to go. Yeah, basically that's pretty much it. If you wanted to, let's say, freeze it, what you can do at the very end is you just do a bake simulation, or bake, I guess. You just do it here after the last simulation. Technically, I guess you could bake either spot on it, but you just do animation and then you just say bake and it gets it all. So now this is baked in. And then from here, you can then have a nice kind of view of it. And if you did a trim nodes, probably right around here before the curved mesh, trim curve, and we had this, and we just did, yeah. If you did this, you can have it kind of growing out however you want, like a fun little animatable thing for you right there. But yeah, so this is pretty much it. I hope this makes sense to you guys and hope you enjoy it. It was a lot of fun making, and it's also a good way of thinking about the logic of these kind of like algorithms for working on it. Anyways, hope to see you guys in the next one. Thanks so much for watching.
Augury.